Take a look at this function. If you want to find the Laplace inverse of this, you'll notice that it is not straightforward because we haven't studied any direct formula for this type of function yet. But if we look at this function carefully, we can rewrite it as product of two simpler functions like this. Now you can see we can find the Laplace inverses of this and this separately. The Laplace inverse of this becomes cos 80, and the Laplace inverse of this becomes 1 divided by sine 80. However, we cannot directly substitute these here and take its product because Laplace inverses don't work like that. For us to apply this, we will be using a convolution theorem, which states this. This is f of s, which we are referring to as divided by s squared plus a squared, and this is g of s, which we'll be referring to as the second function 1 divided by s squared plus a squared, which will be equal to the Laplace inverse f of t asterisk g of t. And when we will be opening this asterisk symbol, we will be rewriting this expression like this. The integral from 0 to t. We will replace the t from f of t with t minus u and t in g of t with u. Similarly, we can also rewrite it as g of t asterisk f of t and replace t in g of t with t minus u and t in f of t with u. Now let's apply the convolution theorem. Before we go any further, let's solve a simpler question using the convolution theorem. So let's apply the convolution theorem here. You can see that we have separated it as a product of two functions, where we can refer this to as f of s and this as g of s. We can take these Laplace inverses and find f of t and g of t, and then apply the convolution theorem. So now applying the convolution theorem, you can notice that I have replaced the t from f of t with f of t minus u and t from g of t with g of u, applying the convolution theorem. Now let's integrate. Integrating this using tabular integration, so it becomes u, 1, and 0, e power minus 5u. Since we are integrating with respect to u, we will be taking this out of the integral, so it becomes this. Now integrating this exponent as well. This is the base. Now applying the upper and the lower limits, when applying the lower limit, this 0 will be substituted here. So this becomes 0. Whilst when this 0 is going to be substituted here, it becomes 1 by 5. So it's going to be minus 1 divided by 5 here. You can see that this is positive t e power minus 5t divided by 5, whilst this is negative t e power minus 5t divided by 5. So this and this is going to cancel out. I'm going to be writing the final answer, and I'll be taking 1 divided by 25 common. This is the final answer we have achieved.